Smart automation, better business. Learn how to optimize your business with Solved.
Okay, welcome to another Solved AI webinar. This is our fourth webinar. Just as a quick refresher, we're going to talk about some AI news and then jump into some strategic top-down implementation advice. So we are right in the middle of talking about once you have a good strategy for the role you want AI to play at your company, the goals and objectives you're trying to achieve, and you've gotten your people access to tools so they can use AI to speed up the little things and find efficiencies in how they do their job, then at this point, we're talking about top-down strategy. How do you use AI and how do you implement AI? What tools do you buy? What do you build to adopt AI as a company holistically? So that's what we're talking about today. Last week, we talked about workflows and automations that use AI. This week, we're talking about agents, which is exciting, and we'll jump into this. We'll start with some AI news, and then we'll jump into the content. Towards the end, I'm switching up the order this week. Usually, we do an AI demo before jumping into the content, but we'll do the demo. I'm going to save the demo for the end because it's going to make a little bit more sense after we've talked about agents. So diving right into some AI news. In the last 2 weeks, since the last webinar, OpenAI released a creative writing model. Well, they didn't release it. They released some output from it and had some cryptic tweets about it, which I just love it. It wrote a short story called A Machine-Shaped Hand. Got kind of mixed reviews, but this is big news. And the reason why is because it shows that reinforcement learning continues to progress outside of just mathing. So what do I mean by that? Backing up a little bit, reinforcement learning is kind of the mechanism at place with what's called reasoning models. So the big first reasoning model was O1. And since then, we've gotten DeepSeek R1, Claude 3.7, Sonnet, and O3 Mini. O3 has been announced, but it hasn't been released. The benchmarks and scores from O3, the full version, are really impressive, but yet to be fully rolled out. These reasoning models really increase the ability, they allow the AI to think for a while before returning their output, and you get a lot better performance out of that. But in order to do good reasoning, you have to teach the model how to reason. And so you need a way to say, hey, this reasoning worked. It needs to get to a goal, and you need to be able to verify that that goal is actually correct. So one area where that's easy is in math. You say, let's just take 4 plus 4. It's a silly example. I guess I shouldn't say any LLM will get that right. Every once in a while, you might actually get that one wrong. But you say, what's 4 plus 4? And it's going to generate 1 million answers. I'm not sure exactly how big the synthetic data set is, but let's say 1,000 plus answers of how to reason through that problem to get to the correct answer and then what its answer is. They're going to take all the reasoning chains or paths that got you to the correct answer and train the model on that so it's a better thinker, able to correctly think through math problems. When you have an answer that's objectively correct that it can self-verify, like 4 plus 4 equals 8, that's much easier than trying to verify something like creative writing, where there's not really an objectively correct answer. This machine-shaped hand is an essay or a short story about loss. It's like 1,200 words. I read it. It is, in my opinion, quite beautiful, but it did get mixed reviews, which you would expect from a good piece of writing. A lot of creative writing is received to mixed reviews, but there's a subset of people that are like, this is beautiful writing. So anyways, again, why does this matter? Coding and math, we already knew reinforcement learning worked, but there was a lot of people still on the fence about, is this actually going to work for domains where there's no objectively correct answer? And it seems like OpenAI somehow found a way to get reinforcement learning and reasoning to show progress in things that aren't as objectively verifiable. So very exciting, worth looking into, worth spending some time on. This is a significant step forward in terms of what can we expect, what's next, where are the walls, when are we slowing down? This train is moving extremely fast. continues to move quickly. This is an interesting development here. Baidu released Ernie X1, another reasoning model. This is a Chinese search company. So they get similar performance to DeepSeek R1 for half the price. That's compelling because DeepSeek R1 was already created at like a much lower price than American models. This seems to have cut that even in half. The main moral of the story here is that the models continue to be less and less expensive. The price continues to decline. That's a pattern we've seen from the beginning. As you train up a big model, the cost to reach that same performance starts to decline very rapidly. It's a lot cheaper. This is one more data point that continues to happen. And interestingly enough, this is a little tidbit. It excels at EQ, emotional quotient or emotional intelligence. So early results seem to like mimic 4.5 or be similar to, and that is GPT 4.5. But this is probably 1% the cost of GPT 4. So it's great performance for dramatically less. So it's exciting. All right, switching gears here, jumping back into our business automation frameworks. This is a super high level 3 steps to success with AI adoption. First thing, you want to make sure you've got a good strategy. Understand the outcomes that you're going for, how you're going to measure if AI is being implemented successfully or if there's ROI. Lay that foundation, get on the same page as an executive team. From there, step 1 is not to start buying a bunch of tools and implementing a bunch of things, but rather giving your teams and your experts that work at your company access to tools and then encouraging their use, so that those people can find little ways to improve the work that they do, find the little efficiencies, the time savings, and a lot of times through that process, the best places to put the money for the strategic initiatives sort of bubble to the top, where they say, we found a way to go faster. We could go even faster, sometimes significantly faster, if we spent money to build a tool that did this or to buy this system. And so it can reveal the best places to do the strategic initiatives. And then step 3, that's where we're at, top-down adoption. So once the use cases become clear, what do you build or buy to implement AI holistically? Often, just as a quick recap from last week, let's jump in and do it this way. The things that you could implement, most tools and services or projects that you might build are going to fall into one of 2 categories. There's workflows, and then there's agents. Every organization is composed of tasks that need to be done consistently. Step 1 is figuring out what those tasks are. In a traditional business, pre-AI, usually you would divide those tasks into different roles that are responsible for a number of tasks. And that's kind of starts to, your business starts to take shape across those roles. This is where the workflows and agents come in. We're familiar with automation. Automation has been around for, a good long time now. Software has been making things more efficient, and workflows fall squarely in that automation category. AI has allowed us to automate more things. There's a few processes that maybe they need some intelligence or some creative writing, just words need to be strung together in a way that describes something or makes sense. That wasn't possible to do before with automation, but now there's a lot more things that can be automated because we can add in a step that consults an LLM or gets some intelligence for a decision that needs to be made or generates some words. But anyways, that would be workflows. Agents are where you have an LLM based automation that can do many things, make decisions and operate autonomously. This is where whole parts of a role or an entire role could be done by an AI empowered system. We talked about workflows last week. We're going to jump into agents today. Just as a quick refresher, let me switch and share this article. Last week we did a deep dive. So keep it high level this week. There's a whole section at the end I want to make sure and get to. Building Effective Agents is an awesome article by the engineering team at Anthropic. This came out a couple months ago, I guess it's been about 3 months. That breaks down the difference between agents, gives some advice on when to use them and when not to, and then talks about frameworks and workflows. We talked about a bunch of different workflows that can be set up, and there's some great explanations here. Prompt chaining and routing and several others, until we get to this evaluator optimizer where things start to look more like an agent. Just a quick recap, this is when you have an LLM that generates something and submits it to another LLM that evaluates that output and says, is it good enough yet? If not, it's going to send it back, and then that's going to repeat until this evaluator says we're good to go. This is where it starts to look more like an agent. The article goes into agents here. What defines an agent is a system that's able to take in action that influences an environment and then measure that environment and see for itself, did we do the thing yet? Is the task accomplished? So a human might give an agent a task, and then it's able to act, observe, and say, is the thing done yet? And then based on that observation, decide what are the next steps, what are the other things that might need to be done, and decide, basically build its own workflow, execute that thing until it can observe in the environment, hey, this is what the user asked for is done now, at which point it can stop, wait for the next task. So let's jump into the anatomy of an agent. The main goal here is to basically be able to conceptualize agents a little bit better, understand what they need, the building blocks of them. I think people assume AI agents are really complex, and there's some complexity, some steps, but ultimately they're a lot simpler than I think a lot of people realize. So an agent essentially is composed of three main building blocks. So you have the AI, which is going to be an LLM, GPT-4, Claude 3.7, whatever it is that you're using, that provides the brain, the reasoning, or the intelligence of the agent. And that can be given a number of ways. We're going to dive into it, but it's stuff that you're feeding the AI to say, okay, here's all the context. This is what I'm asking you for. This is what I want you to do. This is what you can do. You're feeding all of that to the AI. And then you're also giving it a list of tools that it can choose to execute, which are going to do actual things. The limitation with AI right now is really how it works is it's text in and it's text out. So it's going to analyze a bunch of text, and then all it can really give you is text, right? These things they're not embodied. They're not like a persistent entity that exists in a computer. It's a very large math problem that takes words on one side and then words come out the other side. So you need to find some way to turn that output into the AI can use words to choose to execute some tools that you've built for it. And then those tools work, and it can maybe configure the tools or add some context to say, this is what I want the tool to do. So essentially the tools are just giving the AI the ability to act. A robot body would be considered a tool in this framework. The agent of a humanoid robot would be the AI as the brain, and then a bunch of tools that the AI has access to, including like, hey, use your hand to pick up that thing. The tools have nested agents communicating with agents that are operating different parts of the robot. It all gets complex at that level, but one good way to think about it is the tools are sort of the hands and the body of the robot. Breaking this down a little bit further, let's talk about when choosing an AI, you're thinking about price and performance. And that's going to change based on what you want that agent to do. For some things, it's a pretty simple query. Maybe it's just question and answer. It's a chatbot or something, and it doesn't need to know that much. You can use some pretty inexpensive models. You got to figure out what level of performance you're looking for and evaluate your options to keep your costs down. There's some very expensive models that can do impressive things. A lot of tasks aren't going to need that level of intelligence. One place I will refer you to when it comes to comparing models is Vellum AI. Vellum is an AI platform for AI adoption at a company. It's an enterprise platform for AI. They offer some pretty cool stuff. Not going into that at this point. They, on their website, have some leaderboards that say, for the task, reasoning, coding, math, what are the best performing models? What are the fastest models? What are the most affordable models? And then you can do direct comparison, including costs. So you can see Claude 3 Opus versus GPT-4. You can see the different costs and their performance on some of the main kind of benchmarks. And then there's a more in-depth table of benchmark performance and a leaderboard for AI. Pretty cool resources there. So jumping back into context, once you've decided the AI that you need, what context are you providing? The system prompt is basically the part of the context that says, this is what you are as an agent. This is what your goals are. This is how you should behave. So you're giving the agent's personality and an objective with the system prompt. You can have some user interaction. If you have a chat interface or some way for a person to give instructions to the agent, there's dynamic context. In the example we're going to get to in a second, customer service, if somebody's calling in and they need help with a certain product, dynamic context might be information about that product. Today's date, if you're injecting this is today's date, that's context that might change depending on what day it is, what are they asking about, who is it that I'm talking to. That's going to be your dynamic context. Tool definitions, you're going to give it a library of tools that it can use so it knows what it can even do. And memory. So all of this context that you're feeding into the AI, and then all of the information back and forth between the user and the agent, if there is a human involved here, all of that's going to get stored as the agent is doing a certain task. It's also going to store, you want it to store the actions that it's already taken, the result of that, all of that starts to load up the memory. Now, that memory goes into what's called a context window, and those are limited. AI companies are racing each other on who can get the biggest context. So right now, Google has a model that I think has 1 million token context window. Token is kind of like a word. And one word probably equals an average of 1.5 tokens. So anyways, that they compete with each other on how big can we get that token or that context window. And that's the memory. Beyond that, you'll have tools that are usually code. It's just code that's been written or some way to do a thing. It's important that tools have descriptions. So when you're listing out tools in your tool definitions, you say, hey, this is a tool that does this thing. Use it if you want to get this thing done, right? And so you have a good definition for it. Example would be web search. So this is a tool that does a search. If you give me something to search, I'm basically going to pop that into Google essentially, and then return the search results to you, or summarize the search results and return it to you. You want all of that in the definition. So let's take a look at an example. Customer service triage agent. So if you had somebody that's sort of the first line when an email from a customer comes in, maybe you can resolve that person's concern very quickly using an agent, almost instantly, give 24-hour support and have this thing taking care of the easy questions or easy cases to resolve, and then knowing when it needs to kick it over to a human expert. So I put GPT-4 on here just because it's a commonly used model. I'm not necessarily saying it's the best for customer service inquiries. The right idea would be to figure out what you need in terms of intelligence, price it out, and do some experimenting to figure out which models are giving me the right kind of output that I want. So context for this, you might put a system prompt. This is very simple, but you might say something like you're an agent who answers customer questions via email and creates cases when technical support is required. A user interaction might be an email that arrives and says, hey, my computer's been running really slowly. In this example, we're a computer company. Dynamic context could be when the customer emails, we're searching our CRM to say, what details do we have on this customer? And here's their purchase history. So now our agent knows who this person is that they're talking to. Tool definitions, we're going to say you have access to a search knowledge base tool, send email, update case details, and escalate case. So those are the things that you can do. And then we're going to send all of that to the AI. It's going to get stored in our memory, all of the emails back and forth, and all the actions that it does. Those are all going to get loaded up in memory as they happen. And when I keep saying in memory, I want to clarify, I'm talking about the context window that the AI has to work with. If we max that out, we're going to have to start purging from the back or selectively purging things to fit this interaction into memory. It's getting really technical. Maybe we'll come back to that another time. I think that's my point here, is that these aren't infinitely big. In our instance, we get an email that says my computer's been running slowly. First thing, it might choose to search the knowledge base and say, when this computer, I know what they've purchased because I've got the dynamic context. When those computers run slowly, what could be the issue? And the knowledge base might have a list of steps to try. And we might send that knowledge article or summarize the knowledge article for the piece that they need. The agent might say, I'm going to use my send email action or tool to send them an email and say, have you tried turning it off and turning it back on, right? Let me know if those don't work. And maybe our user tries those things and says, yeah, I turned it off, turned it back on. It's still running super slow. Can you help? And at that point, it might decide based on, if we put in more detailed system prompt, we might want to say, hey, if you've emailed once or twice, or you're sensing that they're getting upset, then it's time to escalate. And so what the agent could do is update the case details in your CRM or service software and say, all right, this is their original email. These are the things that I told them to do. Here's what they tried. This is what they responded with. Basically, we're taking all that information, maybe some links to knowledge base articles that might help, popping that in the case details. Then we're going to escalate the case. And that could mean assigning it to somebody else, human, to take a look at. And then that agent can just sort of sit there and do that. And as long as it's configured correctly, provide a better customer experience, a faster customer experience, save your agent's time for things that are more complicated the AI can't handle, and you just get more efficiency across the board, while hopefully making your customers happy. Big disclaimer, customer-facing AI applications, you're taking a risk. You really want to do a lot of good testing, because what's really frustrating as a consumer is when you're talking to a robot and that robot's not helpful. I think a lot of people don't mind talking to a robot as long as they're getting what they need. But if they can tell they're just getting generic answers that aren't helping, then there's a good chance they're just going to try and figure out, whether it's in a chat interface or on the phone or through email, like, how do I talk to a real person? Just give me a real person on the phone. So you don't want to provide that kind of an experience if you can avoid it, but there's certainly room for iterating and testing and working on something like this. And there are companies that are using this to great success and increasing their bounce rate by quite a bit. Customer satisfaction increases. So anyway, it can be done, and it should be done correctly. Something to keep in mind. Okay, before we move into Q&A, I just wanted to talk about some good principles to keep in mind when building agents, and then how to build these. We've got an architecture now, but how do you actually make this real? Start using agents, buying agents, building agents. How does that work? First, I'm going to jump back to our Anthropic article here and talk about some best practices. Can't recommend this article enough for more information. They've got some examples down here, including customer support, coding agents, but there's sort of these 3 best practices to keep in mind and core principles that they've found success with. 1 is maintaining simplicity in the agent's design. 2 would be prioritizing transparency by showing the agent's planning steps, and then carefully craft your agent computer interface through thorough tool documentation and testing. Simplicity is important because there's only a certain level of complexity before these agents start to have a hard time. If they have hundreds of tools to choose from, it becomes difficult to choose the correct tool. You want to keep agents pretty single purpose. Maybe single purpose isn't quite the right phrase, you want to keep them small if possible. Often you can get more success out of several agents that do a set number of things really well, that can invoke each other, that can talk to each other. You say, I'm an agent that does this. There is an agent that does this. I'm going to kick this over to them. So you can find more success with that than one monolithic agent that you try to make able to do everything. So keep it simple. Transparency is important because you want to see the plan before the execution. You want to be able to keep a human in a loop and have that human understand what's going on so that it can correct, so you can correct or course correct, keep the agent on track. And then for just debugging, if you know what its reasoning steps are, you can understand why it might be doing some of the things it's doing and kind of improve on that. And then documentation and testing, you'll just basically saying, build good tools, build tools that work, and test your tools, have right tests for your tools, make sure they continue to work, and then document them. That's helpful for people as well as for the AI. A well-documented tool with a good description, an AI is going to be better able to use or identify that it needs to be used. Some things to keep in mind. All right, last thing, want to give you some recommendations for how to implement these things. This one is called N8N. If you're familiar with like Zapier or Make.com, this is a low code or no code interface for creating AI workflows and working with AI agents. Very cool tool with a lot of possibilities. I'd want to open up the add node window so you can see you can add AI agents just on this drag and drop canvas. You can do an action in an app. They have a ton of different integrations with many tools. Similar to Zapier, there's going to be things that you can do that you can provide to the agents as tools. So you want to connect it to Zendesk, log a case. There's an action for that. You can set up a connection to Zendesk and say, I'm going to give this agent the ability to log a case. Very cool. You can do data transformation. There's some logic, branching, looping, that kind of thing. And then basic running code. You can write code to be executed, make HTTP requests, send out webhooks. For integration and customization, there's a lot of options. I love that they call it human in the loop and that it's even here as an option because this is something that's very important. Here's all these platforms through which your AI agents would be able to reach out. So maybe you don't want it to respond to your customers right away. Maybe before the response goes out, you want somebody to read it. So it can kick off a Slack message or an email or something to a real agent that can read it and say, yeah, that's fine. You're not making anything up or saying anything that's untrue or toxic. So then they can choose to send it, but they didn't have to do the upfront initial work. Lots and lots of things possible within this platform, N8N. Let's take a quick look at this AI agent. It seems complex, but it's very simple to get started. You could build an AI agent surprisingly easily. We've got a place here for the system message. You're a helpful AI assistant that helps the user answer questions about their calendar. Here's today's date. We've got our dynamic context here, where that's going to output as today's Tuesday, March 18 at this time. So that's the purpose of this agent. You can see it's got access to a tool, and that is Google Calendar. You'll need to connect it to Google Calendar. You can get events from a calendar. So that's all we're doing here. And this is what you can do with the calendar. The chat model here, we've just said it's OpenAI. If you were to put an API key in here, you could see which models are available. Yeah, you just drop that in and it's going to now manage its own memory. So without writing any code, you can start to get some pretty cool things done. This workflow essentially accepts a chat message, something like, hey, what do I have going on Tuesday? And then that's going to process through the model, your question, the system prompt, everything's going to get loaded into memory. And then it's going to say, hey, I've got a tool that can get information about this calendar. What's going on Tuesday? And then it will return back to you. It's going to run that through the AI model again, and it's going to structure a response that says you've got a meeting at this time, this time, this time. So pretty simple. Without writing code, got a pretty useful agent there. Other platforms for low-code agents, Salesforce's Agentforce, they have a ton of pre-built tools and pre-built agents. So that customer service agent that we talked about as an example, Salesforce has that basically out of the box, or close to what we talked about today. And with some light no-code customization, you can get it to do some of the things that we were talking about, like triaging cases, responding, kind of have some control over how many times should it respond before it kicks it over to a real person. You can give it access to data libraries, which are just collections of documents, a knowledge base if you wanted. And then there's more and more coming out with Agentforce, where it's going to have more and more access to information in Salesforce or their customer data platform, which is Data Cloud. Really exciting things happening in the Salesforce platform with Agentforce. You can try or build proof of concepts for free if you're an enterprise customer with Salesforce. They provide some credits. It is usage based, so it's kind of like based on the number of conversations is how you're charged for that. There's a lot of free credits to start playing around with things like this right in Salesforce. So super exciting there. And then a couple platforms that are not no code. In fact, they're code, strictly code, are Pydantic AI, LangGraph. There's a lot of frameworks, and they're getting more and more support and cool stuff all the time. So internally at Solved, we've been a big fan of both Agentforce and Pydantic AI for some of our more code-heavy AI automations. All right, I think that just about wraps us up. Of course, let us know if you have any questions. Feel free to reach out. I'll show you really quick. Our website is solve.cloud. If you come here, click AI Expertise, you can set up an AI Adoption Accelerator workshop or set up a time to talk about what that is. The purpose of that is to get you up to speed very quickly. So the main steps that we talked about, defining a strategy, documentation, training on how all this works, and then moving into how to empower your people using AI, how to use it safely, and then what strategic initiatives might you implement to start automating more of your business. That's the purpose of that. Of course, if you just have general questions, feel free, just click on this Let's Meet. You can schedule a time to meet with us, and you want to communicate through email, feel free to reach out and contact us here. Couldn't be easier. We're happy to help with any business automation task that you can think of. If you just want information, want to learn more about this, happy to help you however we can. We are quickly moving into an era where business is more and more automated. It's not even fully clear yet exactly how that's going to look, but there's a lot of possibilities. At Solved, we're implementing them more and more all the time and automating more and more of our business. It's really exciting. We want to help you do the same. So feel free to reach out. Thanks, everybody.
Thank you so much for watching. We can't wait to help you automate your business. Please like, comment, or subscribe for more.